Microphone check. Good, that works. All right, just getting set up here, folks. We'll get started in a little bit. Programming. And maths. Mathematicers. Should I pull out the tablet? I don't think so. I don't think I should pull out the tablet. Alright, 6 o'clock now. Oh wait, one more thing I gotta do. Gotta make sure I can see chat. Okay. Hello and welcome to Handmade Hero, or I'm sorry, Programming and Math. And we're gonna do some programming. More programming than math today, really, mostly programming. Not a lot of math. As usual, if you have questions about anything that I know about, not just programming and math, because last time I had a lot of interesting questions about the game industry in general, and those were fun to answer, which I work in. I'm a video game programmer anyway. If you have any questions, you can ask them at any time. I will answer them all the time. And let's see, we're gonna do today asynchronous resource loading. This is kind of just an experiment of mine. Been playing around with this, how to load resources asynchronously for the purposes of like streaming in a game. If you have a really large world and you want to move from section to section without having a loading screen, and you want to do like, you know, as you go past this, you go through this twisty hallway and it loads this stuff, and as it does that, it unloads the stuff behind you, or that sort of thing. It loads in the next section while you're walking through this hallway, just like seamlessly. It does it in a background thread. That's the sort of thing we're doing today. It's gonna be really fun. I think it's fun, you know. Other people might not think it's so fun, but I think programming is fun. What can I say? So let's just do the one last thing here before we get started, which is post about it on Twitters. What on earth is this? Orlando Bloom admitted that he was shocked. I don't even care. Good morning, H to IDE man. You were here last time. Welcome back. What was it? Oh yes, streaming now about asynchronous resource loading. Really different from what we did last time, which was a compiler. So, I don't know, kind of changing everything. No more JavaScript for now. No more compilers. We're gonna do this instead. I'll try and give like a quick overview of what's going on, because I had a renderer. I don't think we ever actually have gotten to the renderer. First stream I did, we did like a reflection system, which turned into just a file format library sort of thing. And then the intention was to take that file format library and plug it into my existing renderer. And when I went to do that, I discovered that my resource loading code was awful. And so eventually we're going to get around to an actual renderer, but now that all the file format stuff is done, well, it's pretty done. It's functional enough that I can start using it. It needs some work still, but anyway, all that stuff is done. I was going to get back to the render and actually be showing things on a screen, but I don't know, my resource loading code was kind of bad, and so I want to redo that first, I think. So we're going to do that. Hey, it's McGrath. That's fine. If you've streamed at all, I've been interested in watching your stream, but I haven't been able to find any stream that you do talking to Sean. So let me know if you stream so I can check that out. Anyway. So we'll give just like a high level, give you a high level idea of what's going on here. Ooh, where do I start? Where do I start? Let's start with main. Okay. Okay. This is the name of the game I'm working on, Grotto, so that's what that means. There's like an object that contains all of the stuff in the game. It's really straightforward. We initialize it. And then, oh wait, this is not even the right main. This is a wrong main. Where's the right main? No, this is the, oh, here it is right here. Yeah, so this engine's structure is kind of weird because I want to do like rendering in another thread and asynchronous resource loading. It's pretty important to the, oh yeah, that's too bad because I work. Wait, EST. No, then I definitely can't do that because I work. Well, maybe I could load the stream up at work. That's why I've never been able to see your stream because, well, I'll do this later. I'm not going to go to my email right now. But, oh yeah, backend database programming, not so fun to watch. See, that's been the same stuff with the compiler stuff I've been doing last few weeks. It's like, it's not, I don't know. I got the feeling that most people didn't really get into the whole compiler thing as much as, I think compilers are amazing, but most people didn't really get into it so much. So maybe resource management will be more interesting. I don't know. We'll see. Oh, I was gonna show you what I did for, oops. Okay. So I think I've shown you this before. And I gotta get the mouse out. It's fine. I got headphones and stuff. And everybody swears at my work anyway. Hell, I swear at my work. Just finished your Java final parsing stuff into SQL. When you say final, do you mean like of a class? Oh, I gotta clean up in here. So, let's see. Here we go. This is not a very good example, is it? Yeah, I have the resolution a little bit too high for it to be a good example, but this is like multi-sampling right here. Let me see. Let me see if I can make a more effective demonstration. Like that? No. Put it over here. Something like that. Yeah. So it's doing multi-sampling here, which you can't see very well, unfortunately. Because the resolution is kind of low, and so it all blurs out anyway. But I wanted to show you how I did that. Compilers are pretty esoteric and have a pretty large burden of knowledge to get into, so I can imagine them not being super popular. Yeah. I mean, a parser, if you just take the parser, which we were mostly in the parser, I feel like it's pretty straightforward. But I don't know, people in the stream weren't into it, so we'll go back to something. We'll try something else this week. Maybe we'll go back to it later. I don't know. What am I doing? I don't even remember where this code is anymore. I think, yeah, light maps. Light maps. This is it. So it's exactly like Java well, we were in JavaScript last week. We're in C++ now. We switched. Sorry about that. So this is exactly like how a GPU does it, basically. Let's see. I don't even remember how this works anymore. This is all SIMD. I have this construction that's basically the 3x4 SIMD vector. How did this work? Right. So it does a bunch of samples. It does a few samples? Oh, yeah. So, it does like a few samples. And if some of them hit but the others don't, then it treats it as a multi-sample pixel. And then it does like the long way. It loops through all of the multi-sample offsets and does like an individual ray for each one. Whereas if they all hit or none of them hit, then it only does it takes that value. I don't know. Does that make any sense? So it calculates a light value. It does this intersection, it finds a trace mask, and then it uses that it does the trace mask to figure out if it should use the light value that it calculated. But if only some of them hit, that means we're on an edge. And so then it goes back and it does a full calculation, like a full anti-aliased high resolution. You say anti-aliased, which has a different, doesn't really mean the same thing with ray tracing, but you get what I mean, right? Like it does a full computation with 8, not just 8 vectors, but 8 3x4 vectors. So hopefully that makes sense. Yeah. So the advantage to that is that you still get, at the boundaries of things, you get smooth shadows, but then you're only doing the extra traces to get those smooth shadows on the boundaries. Most of the time, if you don't have a lot of boundaries, which you usually don't, you do only, a few traces per, maybe 1 trace per pixel or something like that. Oh, you missed everything. Okay. Starting from the beginning. Let's see. For each light here, it's really simple. It's just like to unplug your modem. Sorry. For each, I can probably explain it better the next time. So it's cool. It's cool. It's doing SIMD stuff, and it's just like GPU multi-sample stuff where so it has this 3x4 where it's doing 4 traces here. It's doing 4 traces at one time in SIMD, right? And then it gets this trace mask to see which one of the 4 traces hit. And let me see, where is it getting the... Yeah, so it's doing slight offsets. It's doing these offsets for the 4 traces. So each pixel that I'm calculating gets 4 traces to it. I'm repeating myself a lot, I know, but and then it does this calculation. It gets a mask, and if all of them hit or none of them hit, then it will just take the value that it calculated. But if some of them, but not all of them hit, then it goes and does the whole 8-way multi-sample for that texel that it's rendering the light map to, right? And then it does a loop. For each one, it does a more intense thing here. Traces a bunch more times. So then the point is that it only will multi-sample on the boundaries if some of the traces failed. And it's almost as fast as if you take this block of code out right here and always use the unmasked value, it's almost as fast as that. It's super fast. You get this almost for free, and then you get a nice smooth line, and that gets rid of the the jagged edges in your samples. Except that the caveat is, and I wonder if I should set up the tablet for this. Maybe I'll just draw with the mouse for now. The caveat is that your samples tend to look like this, right? Because until that first sample misses, it thinks that none of them hit, and so it doesn't turn on the multi-sampling. And then same thing with once all of them start missing, it turns off the multi-sampling. So in this area, it looks really good. And outside of that, it usually looks okay in practice. That will only work with solid colors though, not textured walls. Yeah, I'm just doing this for light maps. Yeah, exactly. I'm just doing this for the shadow calculation. So, exactly. Okay. So that's pretty cool. But we're not doing that today. We're doing resources. So let's see, where am I? I don't even remember. So I have an engine. The engine, like, I discovered that, am I for hire? No, sorry, not for hire. Pretty happy with my job. It's really simple, yeah. And I stole the idea from GPUs, so there's nothing creative about it. Where was I? So I discovered that I can't do, like, all of the input and rendering I have to do in the main thread because SDL wants to be in the main thread, and because, like, OS X wants, I'm on OS X right now, but I think this is also true on Windows. OS X wants all of the input and windowing stuff to be happening in the main thread. So OpenGL and querying SDL for input I have to do from the main thread. So what I'm doing is, maybe I should open Mischief again. Mischief. Okay. Here's my main thread. Okay. And my main thread is going to be doing input and rendering. It's going to query input and then render. Query input and render. And then over here I'm going to have a logic thread. This is my design. Logic thread. Logic thread. I'm just going to get the damn tablet out. This will only take a moment. Oh no, I don't have enough USBs in my computer. I'm gonna have to unplug the mouse. Let's scooch this over here. Okay. Unwind a cable. Come on, plug in. I think that's plugged in. And the pen, and it works. Great. So this is the logic thread, and this is the main thread. Maybe I can even draw right proper names. Okay. Main thread and logic thread. So logic happens in a separate thread. And so we're going to do logic stuff, and then while we're doing this, we start building up like a render buffer, like a command queue. Okay, so at some point we have like built all of the buffers in memory that we want to ship over to the driver. So when we're done with that, we have a synchronization point with the main thread. Okay, and we send over to the main thread all of our render buffers. They'll all go up to the main thread. Okay, and then we get from the main thread the inputs. Like all of the input processing has to happen on the main thread because that's the way the OS likes to do it. And so the inputs go to the logic thread, and so the logic thread can use those inputs to process the next frame. And then it will start again on, on doing all the logic of the game and building up render buffers. Okay, so then what does this is render buffers right here, render buffers, and it has to take those render buffers and start submitting them to the driver. Okay, so that will happen right here. Render buffers, submit them to the driver. This whole time data is going out to the driver. And then at the end, you say, swap buffers right here. Swap buffers. And then you get a vsync, like you stall on the vertical sync, right? Like what does that mean? The monitor can only show 1 frame per 60 hertz per 16 milliseconds, or more or less. So if you try and send more often than that, it will stall until the next frame. So when you call swap buffers, that's when that happens. Like, you call swap buffers, and then whatever you sent it, that's all you're going to send it until the next frame starts. And then it happens all over again. You kick off another one, and it just happens like this. So this is probably like the simplest model for a multi-threaded engine. You do inputs again, send inputs over here, the inputs get processed. So this is logic frame 0 and render frame 0. Logic frame 1, render frame 1. I guess there was an inputs back here. That is the model. Then somewhere in the logic thread, you have your resource loader. So the logic determines that, okay, we're in a different part of the model now. We have to load we're a different part of the level. We have to load a new model or something, like a new texture, because we're going to do a new part of the level. And so it has to send, like, it has to, okay, well, here's what it does. This is all part of the same thread. Same thread, logic thread, okay? I'm drawing it in parallel, but it's not really in a different thread. So it goes to the resource manager and says, hey, I want to load this texture. Resource manager says, that's cool. I'm going to immediately return to you and not stall the logic thread. But in the background, I'm going to use like whatever the OS Asynchronous IO API is. And that's like the read file on Windows and AIO stuff on Linux and Mac. And it's going to asynchronously start loading things into memory off of the hard drive. And so it's doing that in the background. Again, same thread, because I'm taking advantage of the OS feature, Asynchronous IO. I could do this in a different thread and do an fread on my own, but I'm not going to do that. So it's doing that in the background. It's loading things. Then eventually, it gets done doing that. Like, everything is now in memory loaded, and now I have to tell my my renderer, okay, I need you to actually load this model into the GPU. So at that point, it kicks back to the logic thread, say, okay, I have this stuff in memory. I am building a game engine from scratch, yes, just for fun, no particular reason. Just for learning and all that. Handmade hero style, kind of, for learning. It kicks back to the main thread and says, okay, the memory for this thing is now in memory. The data has been loaded from the file into memory. Now we have to move it to the GPU. So then it will, as part of all the things that it's preparing for the render thread, have a pointer back to that memory that it loaded. Okay? And it will send that to the render thread as part of that buffer of commands that it's queuing up. Sends that to the render thread right here. And the render thread says, okay, I'm rendering stuff, I'm rendering stuff, I'm rendering stuff. Oh, I also have a pointer to all this crap that I loaded, right? And in that pointer, like, it has a pointer to a bunch of memory here that it has to send to the GPU. And so it's making calls out to the GPU. That's going to be one of those calls. It's going to take all that stuff that I loaded. Now we're in another thread, but we're still in the same memory space. So we refer to that memory. We tell the GPU about it, and then the GPU can start like loading it in. And hopefully that doesn't stall the driver. I don't know enough about drivers to know how asynchronous stuff works in OpenGL. So I'm hoping that like the driver knows enough to be like, oh, okay, I can load this in the background and it won't stall the, like it won't cause a frame hitch to copy all this stuff over. So we'll see about that. If it does cause a frame hitch, then I'm in trouble. Okay, so let's see how far we've gotten with that. I'm just gonna press play and see where we're at, because I don't even remember what I stopped doing from yesterday. So here we're in the resources think command, so that's like here. Resources are trying to think about. Move the microphone a little closer now. Resources are trying to think about what async reads have finished, and if we want to like start loading things actually. Okay, so that's fine. So okay, some asynchronous read has completed, and oh, that's right. This is where I am. Okay. Right, so this AIO return, this is asynchronous input output, right? Asynchronous IO. And man, AIO, see, I've already done this. It requires that you call this, should only be called once to obtain the final status of an asynchronous IO operation. Return something other than E in progress and to clean up system resources. However, it's not called at all, it will leak resources. So it wants you to call this thing once, this thing right here, once when you're done with the read so that it can clean things up. So it can free whatever memory the OS has allocated. But then when I do that, it returns bytes read equals -1, which on failure, it returns -1 and sets error to indicate the error. Oh, this is not good. So we have to read error to figure out what the error message is. Finish async read. This is probably not going to be very fun. Hopefully this is an easy fix. Why did it? Well, hold on. Let's look at what's in this control block. That's probably the first thing that I can do. Oh, everything's null. Why would everything be null? That's very interesting. Everything's 0. That's probably why. All right. So let me see. This is probably just like I screwed up somewhere, honestly. That's probably what this is. So let's see. Control block. Oh, you know what? I know exactly what this is. It's my phenomenal hack. I shouldn't have hacked. If I'm on OS X, why not use KQ or Grand Central Dispatch? I don't know about those things. That's why. You can get completion notification events from a single queue query. Yeah, I don't want to do anything event-driven, because I'm trying to just keep this simple so far, but let's look at KQ. I mean, I could do it event-driven. Okay, so this looks like it's pretty standard. Kernel event notification mechanism. Maybe you can use this for I/O? What is this? This is just a generic event thing. KQ maps pretty closely with Windows IOCP, and it's the best shit ever. I've not used Windows IOCP, but this looks like it's pretty generic event queue stuff. Yeah, see? Okay, so let's see. So you're just saying like, you're just saying I should use KQ to get an event for when the thing is done. I think that's what you're saying. And I can do that, but for now I want to do it without events. I want to keep things simple. Like I don't like event callbacks because like I know that like good programming design you're supposed to do everything in event callbacks and not have the busy waiting thing. But you have more like, so when you're working in event callbacks, you have like object lifetime problems and you don't know, like, you have a lot, there are no callbacks, really. You pull a single queue object without having to keep track of everything that's running. Oh, that's pretty interesting, actually. Okay. If you have like a window, like a, I don't know, like a link that I can look at to see how KQ works, because I've never heard of it, and I can evaluate it. And I'll take a look at it offline because I don't want to like derail what I'm doing to learn KQ. And I'll take a look at that, and it sounds like it could be useful. So, and thank you. But I know what the problem is right here. It's this awesome hack that I do. Let's see if that's correct. This control block has stuff in it, and then when we return, where are we? Right here. Yeah. Oh, no, it still has stuff. The phenomenal hack is that I want to hide the contents of the async handle, and so I just have a bunch of size t's right here, and then actually inside I have the actual control block, so that like, you know, this is platform specific code and I don't want to expose it, so the actual data goes inside the CPP file, and out here it's just trash. That's why I'm doing that. Don't have an example specifically for KQ, but IOCP is pretty similar. Solaris added it right after Windows did, but BSD waited because Microsoft had a patent on it. Wow. How could you get a patent on event handling? I don't know. You know what I'm gonna do? I'm gonna pull it up in this browser over here and check it out after the stream. Okay, so that looks okay, actually. There's trash in it, but the trash has the values that probably correspond to the, you know, the actual data. So that's weird. So the data's there. New async read. So return that. And now vertex read, mread. Yep, still has the data. And fragment read. So it reads a vertex. It reads a. What'd it do? Oh, it reads a vertex buffer and a fragment buffer. Fragment read. That has stuff in it too. Yeah, it reads a vertex shader and a fragment shader from the hard disk. And by the way, interestingly enough, well, maybe we'll get to that in a bit. I'll just show it right here. This is the reflections file format stuff that we were working on a few streams ago, and I'm now using it to actually load files from the disk. So maybe we'll get to see that in action today. You use IOCP on Win32 and epoll on Linux to wrap all asynchronous IO. Linux epoll is significantly worse. So I had to do some fudging to make it work like IOCP. I can show you how to do it later if you want. It's pretty incredible. I would like that. Understanding IOCP literally changed my understanding of multi-threaded programming. Oh, I would definitely like that. That sounds cool. I don't know, maybe we should detour and do that right now, honestly, if it's as cool as you say it is. I want my understanding of multi-threaded programming to be changed. Because when I'm doing, like, you can see what I'm doing. I'm just trying to get, like, the OS to do all the asynchronous stuff for me by using AIO. Yeah, maybe we can have a little... yeah. Yeah, let's do it. Let's hop over to SS McGrath's stream for a little bit. If that's okay with you, Sean. Except, let's not do it the same. I'm gonna do this. Okay, he's gonna be... Is this working? Oh, wait. Yeah, Twitch lets you do, like, crazy hosting stuff, doesn't it? Like, I can press a button and it, Oh, cool, you fixed all the formatting here. That's great. Yeah, like, I press a button and it hosts this stream instead of mine. I don't even know. I don't know how to do that. Well, low-tech solution is I'll press here when he's ready. I'll press play here when he's ready. In the meantime... Boop. Now it's all zero. All my crap got zeroed out. I can do it in chat? Let me just do this. Twitch, host stream. Host other stream. Host mode, that's it. I got an email about this the other way and I was wondering what it was. Oh, hey, that's super simple. Okay, we'll try that out when he's ready to, when he's ready. We'll try that out. That looks simple. All the stuff is zero now. And my buffer's null? Oh, I think I must have just... What the hell did I do? How many async reads do I have going on? 2. Did I... Should be up now? Okay. Let's give this a shot. Host SSS McGrath. Enter. 2 host commands remaining. Oh, great. Okay, now let me get my headphones on. Bam, it worked. So that I can hear Sean. All right. Yeah, I don't know if you can hear me anymore, but I'm a go.
Windows, it's a handle, same fucking shit, right? And basically, what you can do is you can, let's see. So you wanted to do file I/O, right? So you use the same handle for all asynchronous events, period, from the operating system, right? The operating system has its own internal scheduler where it schedules inside the kernel. It schedules asynchronous I/O, whether it be from a network socket, from a file, from a network socket or a file. And then what you can do is you can hook up. It's called a completion port in Windows, and it's a KQ event in FreeBSD, and that's basically when it's finished reading, like post a notification that it's finished reading. And the cool thing about it is, and why I said that it really sort of changed my understanding of how multi-threaded programming works is, let's see we file read async. Deal with file asynchronous events. I'm trying to think about a really good place for this. Let's just look at receive. So in Win32, we can receive from, right? It's just WSA receive from, WinSocket receive from. It's the same as BSD socket receive from. But it has this structure called an overlap, right? Overlap is basically the pointer to the structure that contains the information of the buffer that it's going to read to. And that's how Windows works. That's a Solaris and AIX work as well. And what this means is that, let's say you read a file and you pass it this overlap structure. What this overlap structure is like, well, I mean, you can look at it, it's really simple. It's the handle that you're reading and how much data to read, and then if it's larger, more how much data to read, and then where you're reading, right? But what really sort of blew my mind about how it works is you have to keep, when you call an equal or a KQ or an IOCP event, you have to keep and I thought this was fucking stupid at first, right? I didn't understand it. I thought this was like completely broken, right? You have to pass it a pointer to the overlap structure, but you have to keep that pointer around for the duration of the asynchronous event, right? So you say So the TTF structure, right, is the first thing is the file async header. It's a little bit more wrapping than I did. Anyways, it has a file async header. Then it has a sys event as the first thing, and then the first thing in the sys event is the overlap, right? So the overlap is going to be the exact same thing as this, right? So we press cache here. We say cache TTF, right? So this is in single-threaded code, just cache the logo div file, right? So it's like, okay, so it does all this, sets up these file read parameters, sets the header of the TTF file to be the type that it wants to be. Then it issues file read, which calls win32 file read thingy that I have. There's an async header, so the overlap is the async header, sets the data on what to do, blah, blah, blah. Now, IOCP thread. So, set a breakpoint there. So here, I just set up the thingy, blah, 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 everybody's happy. And then when I actually call read file, which is right here, right, so it calls read file. So it's issued now a threaded read, or an overlap, because in Windows we call it overlap. An overlap read that the kernel is now reading something to the data that was specified in the async header actually in the overlap structure. So then I'll keep running, and the result is async pending. So this thing says, async's pending, blah, blah, blah. Press F5, and now in another thread, came directly from us now. Came directly from another thing. Here, and then it's like, oh, this is the overlap structure that was just passed. I can cast it to a sys event. So when I cast it to a sys event, I know that it was a file read. So cool. So it'll go down to the standard for file read, and then it'll unpack. It knows it's a file async header now, right? Because these are the same. Like this address and this address and this address are all the same because they all start with the overlap. So the thing that it's sending you is the first byte, like the pointer that it sends you is the pointer to the structure of whatever you want, as long as it starts with an overlap. So then pass it to an async header, and you're like, oh, what's file name, right? Oh, async pending. What's the, I have more data here. Oh, it's a file read. Oh shit. Okay, my kid's home. I gotta go. But anyway, I think it's pretty goddamn great, if that makes any sense. But I gotta go.
How do I get out of host mode? Unhost. So that was fun. All right. So that was really interesting. I think I get what he's saying there. Yeah, do they really? I've not seen a lot of his streams. Well, I don't have a kid, so, there's that. That's really interesting. So, yeah, because I have this like, this is my platform code. What the hell am I doing in here? I have this async read data structure. Where'd it go? Here. And it's got this guy is the equivalent of the overlapped. I do have a dog that throws up, that's true. It's usually not stream ending, worth ending the stream for, but I have this async handle thing in here, and then let me see. Yeah. I see. So whereas I'm like finding the data in this guy right here and querying it every frame, he just has like results that sit in a queue that he pulls off, and then like, okay, I think I get what's going on there, and that is really cool. Post queued completion. Oh man. That's really cool. I want to learn more about that, because it seems like here's create IO completion port. It seems like a really handy way of doing things, but I'm not gonna figure all that out on stream, because it probably involves a lot of like staring and reading, staring at the computer screen and reading. So we'll continue like this for now, but probably I'll have it set up like that by the time we see each other next. Anyways, that was really cool. Thank you, Sean. Yes, it was useful and made sense, and I see the difference between how I'm doing it and you're doing it. So KQ. Let's go down that road for a little bit and see how we can get KQ to do the thing. So the trick is like there has to be some structure around here in Unix land that does the equivalent thing. Could be this guy. Oh man. Yeah. Where was that overlapped thing? Overlapped. It probably says all that in here. It merged file offsets with overlaps, so that's not exactly intuitive. Yeah, Windows API made a lot of dumb decisions. Yeah. Okay. No offense to Sean, I'm gonna keep going with this API that I have going right now, because I currently understand it and I don't want like a lot of ums on stream. But yeah, I'll check that out by the time. It looks pretty amazing. I'll check it out between now and next week. You probably didn't hear me say that because you just said be right back, but all right. So what's going on here? So oh man. There, we're trying to figure out why this thing turned null, basically. So where are we at here? Put the spray point back. Yeah, so it's fine. I'll just type it out just in case. Oops. That stuff was pretty amazing, but I don't want to try to figure it out on stream, so I'm going to deep dive it later. for now continue with this. FYI. All right. Right, so at some point it's zeroing out my data for some reason. I don't know why. So let's see here. Okay. Yeah, I don't need that breakpoint anymore. So vertex read. Not null at this point. I have data. And then let's see. Let's look at async reads here. Async reads, elements. Oh, here it's all null. Oh, you know what? I'm probably not writing to the correct thing. This is weird. Address of this 102.02.CB0. This is a different address. What is going on? How many things have I? There are only 2 things. Okay, something is really weird here. I think. Okay, 0. So then the first element is at E2BO. So E2BO. Vertex read. So vertex read is at E2BO. Okay. Vertex read. E2BO. First element. Oh, it changed. Oh, I'm dumb. So, of course, if you push back on an array, it invalidates any previous pointers you got from it. It's a pretty silly bug and easy to fix. Gonna do both of my pushbacks first, and then except that's not right, is it? Dot back, something like that. Now let's do it this way. Dot length -2 and dot length -1. There we go. So this time I push 2 things back, and then I get the memory for them after I push them back. So that should fix that bug. Yep. Oh, that doesn't compile. No member name length size. It should be size. So that was pretty dumb. That probably works. All right, so 2 pushbacks, and then grab the correct pointers, and now they're not going to change next time because I'm not going to do any more pushbacks until the end of the function. So grab the information, the vertex and fragment files that I want to load. Okay, so now I have them in memory. There's my file. And this pass.tvs, that's a VTB format file. That's that library we were working on a few weeks ago. This file was written using that library. But I'm not gonna actually like unserialize the data yet. I'm just like grabbing the raw data from the file. Okay, so vertex read, that has junk in it. Good. All right. So now, when I get to this code, here it is. It's still there. And what does it return? Is it complete? True, yeah. So it's a really small file. Big advantage that KQ has over IOCP, at least until server 2012, is you can use 0 copy sockets. I don't know what a copy socket is. But you pass a write buffer to the K event, and the kernel will directly write to it from the NIC with no extra mem copy in the kernel. Oh, that's nice. It's a big reason why Erlang is so efficient on FreeBSD. Interesting. Yeah, I see what you mean. So it gets rid of the extra copy that it does when you get it state and you have to copy it to wherever else you want it to go. That's handy. That's pretty handy. I really have to learn this stuff. So this probably should not crash anymore. Oh, but it did. What? Bytes read is still -1. My control block is okay this time. It's full of zeros. So I guess nothing was copied. Let's see if I can print this. Oh, good, I can print this. Okay, error number is 16. What does that correspond to? Oh, I don't even want to know. Ugh, what does 16 mean? There's some header in my system somewhere that will tell me what 16 means. Hex 16, that's 24. Ugh, I don't even know where to find that. It's got to be one of these two. Oh, this is the worst. Let's see if I can do it this way. Oh, good. So 24 is too many open files. What? Did I do that math right? That was 22. A dir. Invalid argument. What? Okay, well at least that's documented. The argument does not reference an outstanding asynchronous IO request. That's what? Maybe I should actually see what this thing returns instead of checking that it's not yet in progress. AIO error returns an int. Let's do this in Sublime. Here. And here, int. Okay. So now we can actually see what the error is. Let it print out. Oh, I already had it written here. I didn't need to copy it. All right. And then step in here, and then step here. Okay. So now error is -1. Uh-oh. I don't even know what -1 would be. Oh no. Oh no. So, control block. Huh. I wonder if the problem is that, see, I'm making a copy of the handle right here with the phenom hack. I make a copy of the handle. I wonder if it's indexing on like this pointer, because where is it? Oh wait. Oh wait. Oh wait. Oh no, that's not the problem at all. Well, the problem is that I never actually call AIO whatever the. Oh, the problem is I'm stupid. I never actually call AIO read. Okay, well. Am I just blind? Or do I never call it AO read? Yeah. Okay. I'm just an idiot. Here we go. So handle dot oops. Control block. This will fix all of our problems. I was in the middle of doing this last night when I had to stop, and now I'm just picking it up where I left off yesterday. So, you know, things are fun. All right. So this time, it's still giving me -1. Let's see, is AIO read return anything? Return 0 if successful. All right. Let's see what that gets us. Unused variable ret. I know that. I don't care. Aw. Actually have to use it. Ret equals ret. There. Are you happy? Oh, I know. I know. How do I make this error go away? Ret equals ret plus 0. Will that make it go away? Good. That sufficiently confused it. Okay. So ret is 0. 0 successful. So then it was successful. Oh, you know what I should do? I should say. Yeah, that's what I should do. So let's see, did it write anything into the control block though? Not really. I don't know what all this stuff is like. So what I'm worried is that it, yeah, like that it's gonna index on this handle, on this pointer that I send it, which I then copy to something else, which would not help at all. But just to test that theory, I'm gonna change the way this. I'm gonna change the function signature here. Like you have to provide it a handle. Just in case like it's stashing that pointer somewhere. That would be, it would explain the problem anyway. Yeah, and then I'll have to do this. And then I'll have to do yeah, and then I get rid of this. Move this up here. Actually, this can be a static assert. I wonder if my compiler supports that. Yeah? No? No. Oh, oops. Damn it. I need a pointer. Static assert with no message. We'll give it a message. Why not? There's your message. No matching function call for start async read. Why would it? Oh yeah, so now I have to do this. Okay. So making sure that this in particular is not the problem. If it is the problem, then I'm pretty in trouble because I have this thing in this array, and the array could change location in memory at any time. And if it doesn't like this thing moving around in memory, then that's bad. Okay. So return value is 0, which is the expected return value. Everything good so far. Okay. Good so far. Good so far. And we'll let it run until... Oh, there's another one of these. Let it run until here. Now we read it again. All this stuff's still in there. Yeah, and I get a -1. I don't know, man. So let's try something else. So that wasn't it. It's not... In fact, I think I want to put this back in that case. It's not that it's holding on to the handle. Something else is going wrong. So I'm going to put this back. And I'm glad that's not the problem, because that would be a pretty bad problem to have. And I think a design fault on their part. But they didn't do it that way, so I'm happy. So putting all this back. Okay. Putting back the phenom hack. And now I'm just gonna immediately read AIO error from the control block and see if that gives me any different result. And there's an error. No, it's okay. No, it is an error. What is it? Unused this crap again. Oops. Oh my goodness. Why would you do that? I shouldn't edit things over here. I should always edit things over here. I wish I could set Xcode not to let me edit things over here. Because I always forget. I do know some JavaScript. Yeah, it's not my favorite language to write in, but I can get around in it. My two previous streams, I was working in JavaScript. Oops, I should have done error here. I can probably answer any questions you have about the language in general, but not about any particular JavaScript frameworks. If you need help, I'm happy to help. I like to help. Helping is fun. Okay, error is 36 here, which actually I think is... Should have done this. What is E in progress? 36. Yeah, good. This is fine. This is working. I'm learning, and in HTML file I put body onload set date. And it doesn't work. I believe that if you have your HTML here, And you have like a head or whatever. You have body. And then you have a script tag. I believe that if you just put set date here, it should work. You know? And that it runs all that stuff when the page is loaded. And then, well, hold on. I'm not terribly up with my JavaScript, so let's do a little detour and because there are like two parts to when a page is loaded, and let's see. Yeah. Right, so like there's when the page is loaded, and then there's when the document object model, the DOM, is ready. And there might be even more. Let's see. .load. Oh, this one's deprecated, it looks like. But what did it do? It's a shortcut for okay. Oh, I see. So this is not what you want. I think this is what you want here. So if you use jQuery, then I think you can use this .ready thing. Oh, actually, this looked like a good thing to read. What's going on here? Well, maybe that was not a good thing to read. Anyway, yeah. So the long story short is there are a bunch of different events that happen as a page is loading. You want to kind of get the right one for what you're doing, because JavaScript is very event driven and like different things happen at different times. So you want to figure out what the right one is. But I wouldn't like so putting stuff here like in line in the in the HTML, I think it's generally a bad idea. I think most JavaScript people would kind of frown at that. I think generally you want to do things like not even here in like in a script tag. You want to like have some JavaScript file, and you want to put the actual code in that JavaScript file. It's a little neater that way than this is a JavaScript thing and this HTML thing. You get kind of a nicer separation. In the JavaScript file, you put the function set date, but on the console it says there's an error on HTML body onload. But if you copy, yeah. So your code's probably fine. You just need to like, I don't know if you're using jQuery, but you can maybe use jQuery to do that. Or anything like in the global scope in your JavaScript file will be run when the page is loaded. I think if you don't need to access the DOM, it should be fine to put stuff there. Maybe that will work for you. That's what I would try anyway. And hopefully I understood your question properly. Because sometimes I don't understand questions. Let's do this. While. Oh, wait. I'm not editing here. I'm editing here. All right, now this is super bad because it turned our asynchronous read into a synchronous read. But I want to see what happens. Actually, I'm going to do it this way. I'm going to do it a little differently. I know, I used a goto. It's so ugly. It's gross. It won't be there forever, but it's just a really simple looping construct. That I want to, use and make sure everything is working properly. I'll delete it later. I just want to see what's going on with it. So E in progress. Wait, let's see. Error is 0. Wait, error is 0. Oh, so it's already done. Jump to definition. 0 is, I guess 0 is no error, huh? 0 is everything worked fine. So it's not going to... Oh, I got the logic backwards, so that doesn't help. All right. So it's not going to go back up. So that worked fine. So, I'm so confused. Let's see if AO return works properly as well. Unused variable bytes read. Oh my god. Bytes read greater than or equal to 0. Okay. Not going to complain anymore, right? One thing you got to give Xcode is that it compiles a lot faster than the command line. Okay. Bytes read. Yeah, it's an actual number of bytes. So why then is it... What? Handle control block. Yeah, this is the same data as before. I don't know, man. Not M. Oops. So let's see what data it loaded. Yeah, there's actual data there. It looks great. There's even some fun text here. mat4. Which is probably the text of my shader. Yeah. See, I don't know, a lot. Yeah, like here's all the text of my shader. So that's fine. So when I shove all this stuff into the same function, the AIO stuff works properly, but when I put it in different functions, it doesn't work. So that's weird. It's gotta be because of that control block. Being copied somewhere else or something like that. Okay, let's do this. Let's take this stuff out, or at least I'll if zero it out. All right. And then we'll put an assert here, and then we'll look at the pointers. We don't care about the pointers. It shouldn't care about the pointer that I pass into it. Like, I don't think it's comparing pointers. It's just looking at the data. It's got to just be looking at the data that I pass into it, and then like comparing the information that like it's given in here. I don't know. Well, this is disappointing. This is not what I wanted to be spending the stream on, honestly. That's like, Okay, you know what I'm gonna do? 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 Let's go back out here and immediately call this guy. Like that. Immediately step back in here, and now look at the error. See, -1. Okay. I don't even... Control block. All of this data looks fine. All of this data looks fine. Okay. Well, in that case, I'm gonna put this back to this way of doing it. Async handle. I think I will just like to get rid of some variables here. Something is very funky, and it's obviously something that I'm doing. You know. And at least we get to get rid of the phenom hack. Oh, I forgot to... put this static assert back. All right. So... I think that should do it. This guy goes here. Okay. So we clear all the memory out of this control block, which is good. Fill it in with our own stuff. Call read. Read returns 0, which means it's fine. Then immediately go back in and call, see if it's complete. We get results. The result's 0. Okay, so now it works fine. Now it works fine. So what was the address of that? What was the address of that thing that I just passed in? What was that address? Yes. And the address was A928. Okay. So now if I continue, well, I have to do this again for the second one. Okay, okay. O928 and A8CO. I'll probably remember that. O928 and A8CO. Then I continue over here. And now I step in here. And now I have 2340. Different pointer. But that should be okay. No, that should not be okay. That should be not okay. 2340. Is the same data there? Same data's there. But the pointer has changed. I think I'm crazy, man. The pointer definitely changed. Oh, man. What is going on here? This pointer is 5928. Everything's fine with pointer 5928. Okay. Let's look at this guy. Let's look at this guy. Let's look at async reads. Maybe not. What? Oh, because I copy it here. I copy it into where it's going to go. Oh my God. Okay, let's do another little test here. Let's do another little test. I'm just going to like cry if this is the actual problem. So I'm going to take one control block. Okay. Control block 1 and control block 2. Then I will clear control block 1 and fill it in with all of the stuff that we want filled in. And then do AIO read on it. CB1. Then I will say CB2 equals CB1. And then do AIO error with CB2. Should be fine. Should work fine, right? Should be no problem. Use it. Oh. Oh, and now it's going to complain that I didn't use the variable. V assert. There. Good, whatever. I don't even care. So it shouldn't matter that I copy it over to another construction. Actually, I'm going to do it this way. Shouldn't matter. I'll do it once for CB1, once for CB2. Shouldn't matter, right? Should not matter at all. Because these functions should like store their state inside the struct, and I can copy the struct wherever I want, and then it just remembers. That should be the way it works. But I don't know. I might be taking this for granted. I may be taking that for granted. If I can never relocate the struct after I use it, I am programming an asynchronous resource loading system, and I'm really bad at it apparently, where like the game loads resources in the background while you're moving from place to place so that you don't have to have a loading screen. And that's what I'm programming, but I'm having trouble with the asynchronous read operations. So let's see. So that return value is 0, which is correct. And then we do a read from it. We check the error. The error is 0, which means everything's fine. We copy it to CP2, we check the error again, and we get -1. That's it. It doesn't like us copying things. Now I'm sad. Now I'm really sad. Maybe I should read the documentation. System call allows the calling process to read that many bytes from that descriptor, beginning at this offset, into the pointer pointed to by buff. Call returns immediately after it's been enqueued. May or may not have finished by the time it returns. That pointer may subsequently be used as an argument to AIO return and AIO error in order to determine the return error status of the enqueued operation while it's in progress. So it does care about that individual pointer. If the request could not be enqueued, then the call returns without having enqueued the request. Oh, I'm so sad. Yeah. The control block structure and the buffer must remain valid until the operation is completed. For this reason, the use of auto variables is discouraged. Well, yeah, but I should be able to push them onto a freaking vector. Okay, it's not so bad, I think. Uh, I'll just have to like manually allocate them instead of allocating them as part of the buffer, but that's more manual memory management that I have to do. So I'm not very happy about that. It shouldn't have indexed so much on that pointer. It should have just stuffed whatever data it needs to do the operation into that structure and then referred to it later. But because it does that now, you know. Anyway, so now I'm super sad. It's fine. I can work around it. I'm going to put a little note here that says, note, do not relocate the async handle memory after this call. Some operating systems like OS X don't like that. I mean, it's a pretty standard thing to do to relocate memory, and so that means this is gonna like cause bugs and stuff. I don't know if there's really that much that I can do about it. So all right, that's fine. Get rid of all this stuff since I know the problem now. Get rid of pretty much all of that, except for this. Keep the assert. Oh crap. Keep the assert, and then get rid of this. And that's fine. That's fine. That's fine. Okay. And actually, I think I wanna clear the entire structure, not just the control block, because I may want to stuff other things into that structure later. So mem set the whole thing to 0. Okay, good. Fill out my stuff. Okay, good. And in the resource manager, I'm going to have to do something different. New async read. Yeah, this is probably the place to do it. So first, resources. So this has to be a pointer instead of what it is. Okay. And now new async read can return a pointer and return a pointer here. And then I have to say, oh, looks like I already do a valix, so let's do another one. Read. So this is async buffer, and this is async, what is this thing? Control. So how much do we allocate? We allocate size of the handle. Async handle. While I'm at it, I think I'm going to, let's see. This is my memory database. Oh, it has 3 things in it now. I think I'm going to clear it out. Yeah. So that async load is not in there. Not strictly necessary. Just being a perfectionist. Check out -- So valec grotto .text. Good. So clearing that out, it'll regenerate it. So we allocate the buffer and we allocate the handle of that size. We use the general allocator. That's fine. And then we start the asynchronous read. This is already a pointer. We read that buffer, a buffer of that size. Everything's fine. Okay, we can get rid of this. So now that means that, you know what? You have to free all this stuff now. Yep. Let's zero this guy out as well. Equals null pointer equals 0. This doesn't need to be lined up like that. So free the buffer and free the control table, the handle. All right. Did something wrong. Did a lot of stuff wrong. Cancel async read. Oh, yeah, we don't need this anymore. Yeah, we don't need any of these ampersands since now read is already a pointer. Okay. Oh, we need async handle. We need to do a conversion there. Not the prettiest thing. Return read. That should be fine. Oh, this doesn't need to be a pointer. This can still be. Async read is my own structure. So this I can relocate now since I'm not actually storing the async handle directly. So I can copy that around all I want. So this should work fine. Okay, good. Everything compiles. So now, do an async read. Bam. Async read done. Let's clear out these breakpoints now, since I probably won't need them anymore. And, where were we? So that should be fine. Return is value 0, which is normal. This API is not so great because it should, like, return, yep, it's Valak again. I'm still using it. Although I pared down, like, the instances of where I use it, because of, if you remember what I said before about how it's only very useful in a bounded system. So I started rewriting a lot from scratch, and I'm no longer using Valak in the editor or, like, in the tools. Or at least I'm phasing out its use because those are potentially unbounded. But then in the actual game, I should know my memory profile pretty well, and so I'm using Valak there, so I know all my memory ahead of time, and then Valak will do its thing. So this is not a very good design actually. I want to fix this before I go on, because this should return bool now, and it should return false if it couldn't read, right? So if file, oh, what does man open? No, man to open. Yeah, so it returns a number. Open returns a non-negative integer. Oh, it returns -1 on failure. So if I'm -1 here, then I need to return false. I don't think I have to close anything. Now, if this is not equal to 0, then I still have to return false. Still return false. Except that now I have to close the file descriptor. You missed most of the stream. You're gonna go back to YouTube, watch it again. Yeah, Sean McGrath took over my stream again for a few minutes and showed some really cool stuff that I'm gonna try and make use of later. So that is definitely worth watching. So if this happens, I have to close the file descriptor again. Ooh, which I think I actually am not closing over here. Yeah, I definitely have to close that over here too. So I'll do that in a moment. Close the file descriptor and then return false. Otherwise everything's fine, then I return true. All right. So when I finish it, or if I cancel it, in either case, I have to, let's see, close, and then the file descriptor should be in here somewhere. Handle, control block. There it is. .aio file descriptor. And I can do that over here as well. So close the file descriptor if anything happened. I wonder if I do AIO cancel, do I still have to do finish or return? Ah, I don't. The AIO cancel system call will always return. Oh wait, it didn't say anything about that, did I? Not canceled for file to do with raw disk devices. Let's see if AIO return has anything to say about it. I want to always make sure I clean up all my resources here. Returns that, okay. Huh. Doesn't seem to say anything about whether I have to call return if I cancel. You know what? Better safe than sorry. Return. What's the worst that could happen? Probably the OS will know. Not sure if this is strictly necessary, but just in case. All right. So we're going to do that. Okay, so my asynchronous reads should work fine now. Should be good. Everything should be hunky-dory. Oh. Oh, no, that's not good at all. What the hell happened here? Oh, that's very bad. Okay. Okay, that's fine. I can deal with that. Oh, that's a bad bug. So let's set some breakpoints and see where this thing happens. Man, I was hoping the stream would be a little more exciting than this. So we allocate some memory. We start the asynchronous read. All this should work fine. Oh, really? That's where it goes bad? Bam. What? What did I do? Okay. One more time. Oh, wait. $1D70. Is the buffer all right? The buffer should be fine. I allocated the buffer. Yeah, like it's trying to... it's a null pointer, but like... You saw the thread was... Oh, what's this? Where'd my stack go? Backtrace. My backtrace is gone. See, it's not like it's reading from a null pointer. It's that... Oh, this is it. This is it. Oh, wow. That's a terrible, terrible bug that I'm glad I caught now, not later. Where was it? Here. So I changed this. I changed it so that the... Oof, that was the bug. I changed it so that this handle right here is the allocation is different, and so it was when I was doing this mem set, it was overwriting a bunch of the stack. Oof, that's dangerous. Okay, well, that's fixed. Because this guy lives on the stack, and so it was overwriting a bunch of stuff on the stack instead of overwriting this msig handle, async handle, you know, the actual data. Okay. So we do that. Yeah. I'm gonna really quick visually scan all of this for bugs again. So the async handle, no, the rest of it should be fine. Yeah, that's fine. That's fine. Okay, so yeah, take 12. I'll tell you what. That's weird that it didn't hit that problem before. Okay, so we start an asynchronous read. Good. We mem set things to 0. Now it should be the actual data, yeah, or let's look at it through this pointer. Oh wait, this is violating strict aliasing. I can't do that. That would also be bad. Okay. So strict aliasing is you can never have two pointers pointing to the same memory, or the processor or the compiler doesn't like that. So I had the mem set going through, like handle is a reinterpret cast from into handle OSX, so they point to the same memory. So I was mem setting into handle and then reading through handle OSX. So that would cause potentially problems once the optimizer got to this code. So another good thing that I would prefer to see now instead of later. Okay, so this should be fine. It zeroes everything out. It does an AIO read, which returns successfully. Everything's hunky-dory. Good. Return it, right into it. Okay, now I'm going to put this breakpoint here. Oh my god, these breakpoints are a mess. I'm going to put this breakpoint here. I'm going to continue to that breakpoint. Come on. Continue to the breakpoint. Good. This should be finished. So I call finish async read. And good. Good. Bytes read. Should be the correct number. Yes, 2160. Finally that worked. Okay, we can move on to something else. Good. Fix that. Close the file descriptor. So now we have a chunk of memory that has been read from the disk. Good. That should be this buffer right here. So x read buffer. There it is. Good. There's our data. You can see the mat4. That's the beginning of the shader that I'm trying to load from disk. And now we call the... Oh, because this doesn't do anything yet. Okay, that's fine. Now we're going to call the load procedure. Yeah, which is currently actually empty. So... Yep, so let's start writing that code. What time is it now? Oh, it's already 8 o'clock? It took me 2 hours to work through those stupid bugs. Well, with the detour to learn some things from Sean. So let's see. So let's start writing some actual code. First, I'm gonna stash this registration off over here just for convenience. Then registration arrow mload. So it's calling like this load procedure, which let's look at how that load procedure got set because it's kind of weird here. So at some point we're going to register all of the asset types that we are going to load. And we're going to say, okay, for a vertex shader, when you load it, do this. And when you unload it, do that. So that's what we're doing. And we're doing it this way because I'm trying to decouple. It might look weird, like why don't you just take this and put it directly in there? I'm doing it this way because I'm trying to decouple the asset system from from each system that loads and unloads things. So, we're just gonna have a bunch of functions here that do the proper thing. And it says mshaders.loadShader. So I think I'm gonna uncomment that now. mshader.loadShader. Oh yeah, so this is weird. I'm gonna have to pass in the actual data that's being loaded, buffer size. And it's gonna have to return something too. I'll worry about that later. So I have to change the format of this load function so that it passes in the data that you want to load. So back to resources. I have to pass that in here, but I have it. Where is it? It's right here. Read buffer and read buffer size. Okay, so that should compile. It didn't. Oh, I still have a few more places where I have to update things, I guess. Register asset type, load function. No, I updated that. Why is it still? Oh. This needs to actually use the type defs that I made, load function and unload function. So that should work. I should just never say that should work. It never actually works. No member named load shader in shaders. Great. So let's make that. It's complaining because it's true that there's no procedure that loads shaders. So let's see. I'm not going to worry about the return type yet. But we are going to... We're going to write this. Load shader. And we're going to write it here. Shader. Shaders. Load shader. All this crap goes there. All right. So here's where we get to actually use the file format library that I was working on a few videos ago. So excited. I'm going to include it. So let's see here. Assets.format. So this should look familiar if you watched those videos, okay? I have a shader format, and the shader contains an array of strings, which are like the profile of that shader. Like the shader can have switches that it turns on and off, and there's the information. And then each shader profile is just a bunch of code. Okay, so when it's an array of an array. Like each shader profile has a bunch of code for that profile. So this is just GLSL code right here. I haven't done any like converting it to bytecode or anything yet. I can do that later. I'm just trying to I'm trying to focus on one thing at a time here. I can do that stuff later. So right now it's just like a big chunk of code. So the format for this T shader right here is what's going to come in on this buffer. So file formats.tshader.h, I can include that, right? That should work fine. Unknown type name, size T, that's weird. I think that's in this file? Or wait, this file, or no? Oh, it's in this file. Yeah, good. Okay, and then I pass the buffer in here and the buffer size. Okay. For size T. Good. So all of that worked fine. So now here in shaders, I have to actually load this format. So this should be pretty straightforward. Wait, no, let me keep that open actually. Assess format. So let me do this. Using namespace file formats. So I don't have to write file formats in front of everything. And now tshader instance. So we're going to create an instance of the shader. Oh, actually, you know what? Slightly different thing I'm going to have to do because I'm treating vertex shaders and fragment shaders differently. So I'm going to have to say load vertex shader. That's fine. That should be the same code. I just have to write vertex here. And later I'm going to write fragment shader there so that I know if it's a vertex shader or a fragment shader. Because that's important information. It changes how I compile it. So So I just have to say vertex shader right there. Okay. So now I'm loading a vertex shader. So this will be the shader instance. And I call my instance read method and hand it the buffer and the buffer size. And when I'm done with it, I want to, wait, is that true? Do I want to free it? We'll assume for now that I want to free it. Is that true? That might not be true, actually. I might not want to free it, yeah. So I want to store it somewhere, actually. Yep, I totally want to do that. I totally want to store it somewhere. Because I have to have this memory in residence for as long as it takes to get to the GPU. And I can't free the memory before it gets handed off to the GPU. So, well, but this is the memory right here that's important. I can probably free the shader instance. We'll go with free for now. We'll go with free for now. Okay. So then shader instance get format. So that will get me my actual shader. Okay. And my shader looks like this. It has a bunch of profiles. So I'm going to have to walk each profile. So let's make a for loop. K is less than, let's see, shader dot profile, oh, length of the profiles. Okay, so for each profile, we are going to grab the information from that profile. Shader dot profiles. Okay. Okay, and then shader profile dot code should get us. I forget if that will get me what I want. I'm gonna go look at the actual API for this thing to make sure that I'm getting what I want here. And shader profile. Here it is. Or right here. Okay, so code. No, see, I want to get all of the code at the same time. Oh, here it is. Code. Yeah. So yeah, I just want to get the whole thing all at once. And I have it as a uint8 instead of a string because, like, depending like currently it is a string. It's the shader source code. But later it's just going to be bytecode, and so I don't want to like make it a string here. I want to make it like a thing that can actually be bytecode, an array of bytes here basically. So now I have the code, and at this point I think we're going to compile it and make sure that it all works. Unused variable code. Yeah, so I'll just put a little assert here so it doesn't complain. Undeclared identifier via assert. What is going on? I guess I need to do this. Should be automatically included by pretty much everything. But whatever, I'm not mincing meat here. We'll change this to size t so it doesn't complain. Okay. Why did I have to include this here? This should be included everywhere though. You know what I have to do? I have to go into shaders.h. You know, I should just include like common.h, which is a file that I have that includes everything basically. Yeah, that should do it. Okay. Okay. Oh, undefined symbols. That means that I haven't included the generated code file in my project. So I should go do that. Oh man. I have too many files open. So I don't need this anymore, or this. Or this. Just gonna simplify my life a little bit here. Probably don't need that or that. Okay, that's a lot better. I can actually read things now. So what am I doing here? What was I doing? What was I just doing? Oh yeah, so I need to go to the CMake file. I need to include the generated code in my project. So that means need to go to this file, I think? Yeah. And, or no. Is this the right place to do it? I'm not sure. So the generated code is going to be used actually as far down as Tinker. I think that's true. So the hierarchy of stuff that I have here is Tinker is like the very most basic part to the engine. Tengen, which stands for Tinker Engine, but I just pronounce it Tengen, is the parts of the engine that are specific to a game. So if you don't want any of the game parts, like you're trying to make an application that doesn't have any game stuff, you can put that stuff in Tinker, but not not use Tengen. And then Grotto is the stuff specific to my game. So I think I'm gonna be using the like the generated compiled code a lot in not just the game parts. So I should put it in Tinker. And let me remind myself of what that was called. It goes here, generated underscore formats.cpp. Generated underscore formats.cpp. Let me look for another part of the code where I do the same thing so that I can just copy it. Something like that, I think, is what I want. No, something like this. Tinker reflection directory, that's definitely what I want. Oh yeah, actually this is the old places where I include it, but I moved that aside. Okay, so then it looks like not here, but here. That's what I need to do. And it builds. Move this breakpoint over there. Did I press build or not? Play. Good. Build succeeded. Okay, here we go. So, let's make sure my data is still there. It's still there. Hop into this. It didn't do anything. Okay, that's weird. Probably that's just a problem with lambdas and functionals in this debugger, I hope. So I'm going to come over here and put a breakpoint here, and maybe I'll also put a breakpoint here and hope that those breakpoints get hit. If those breakpoints get hit, then then I know it's just a problem with functionals in this debugger. Yeah, there it is. Well, that's unfortunate that it won't step into functionals. I don't know why. It will step into lambdas. I don't use functionals that often. But a functional is basically just a lambda underneath. Okay, so we're going to step in there. And now we get the shader instance. And yep, get the format. There should be only one profile. I think that's true, because this is really simple shader code. And then we pull the code out and bam, there it is. There it is right there. Xcode. Version 3, okay. Define vertex pro, yeah, and then a bunch of other stuff. So great, great. So now, we have asynchronously loaded the file from disk. And then this part right here, I'm not going to worry about doing asynchronously, because the whole point of this file formats library is it's supposed to be really fast, really fast. Like once the data is in memory, you have the data here in a buffer. All of these operations to actually get the data, figure out where in the buffer that data is, are supposed to be really fast, and I don't think I'll have any problems doing that serially. So I'm not going to try and do that serially. But the next step, I definitely need to do serially. The next step is, I'm sorry, in parallel. And the next step is telling the renderer that, hey, I have a shader that I want you to compile. Okay, so that's the next step. How are we gonna do that? How are we gonna do that? Here's my renderer. Now I have a lot of thinking to do. My renderer is all in another thread. And what I'm intending to do is like build up like a command buffer of things that I want the renderer to do, and then pass that to the other thread. And I haven't built most of that machinery yet. Let's do an experiment though, actually. I'm curious. I'm curious what will happen if I try and load a humongously large file. Like, how long will that take? So let's do this. Let's go to, so I've tested what happens if I load a small file, and of course that's fast. But the point is what happens if I load a big file. Like, it should be asynchronous. It should be asynchronous. And if it's not properly asynchronous, then everything I've been doing here is kind of pointless, right? A small aside to that, I don't like that there's so much shader specific stuff sitting here. So to do, make it so that there's not so much shader specific stuff in the resources class. Decouple more. Decouple more and better. This needs to be handed off to the actual shader stuff, and it shouldn't know anything about vertex and fragment shaders and that sort of thing. Okay, so let's see, where was I? So step one is to make a over here a really humongous file in the place of this file. This is a 2 kilobyte file, and there should be an easy way to like I want to just tack a bunch of stuff, like a gigabyte of information, maybe not that much, no, a gigabyte, onto the end of this file right here, mgui.tfs, which is my fragment shader file, and then make sure that it actually is loaded asynchronously, as in that the program is still responsive while it's loading all that stuff. So let's see what I can do. I think I'm just going to use the dd command. I don't even, maybe I shouldn't do that. I don't even know how to use the dd command. What's a big fat file that's probably sitting somewhere in my hard drive? Or let me do this. Linux create large file with dd. Perfect. I don't know. Yeah, maybe a gigabyte is too big, but how do I create a large file instantly with dd? That's not what I want. Fallocate? What the hell is that? Pre-allocate space to a file? No, I don't care about that. Just give me the dd part. dd path to input, path to output. Block size 1, count. Okay, this is what I want basically. So dd dev 0, so I'm going to copy a bunch of stuff from dev 0, which always is like a file that pretends to always be 0. Out file, I'm gonna copy it to dev stud out. And then I'll pipe it later. Block size equals 1. Count equals 100. Yay. Oh, wait. That didn't do anything. I wanted it to print out to the terminal, but it didn't. I'm disappointed. I'm sad. Okay, how about this? I'll just give it exactly the file that I wanted. Let's see here. Install shaders imgui.tfs. Okay. Now, if I look at that file, it should be exactly 100 bytes. Install shaders imgui.tfs. And it is exactly 100 bytes. Great. So now I'm going to set block size to 1024 and count to 1024. And that should give me a megabyte file. 1 megabyte. Great. So now I'm going to set block, let's see, count to, I'm just going to add some zeros here. There you go. That should be 100 megabytes. Yeah, that's taking a while, isn't it? Great. Actually, it's good that it took a while. Ooh, that's a gigabyte. Oh yeah, that's 1,000 megabytes. Yeah, I don't want it to be that big. I don't want it to be that small either. No, see, so the fact that this takes a little bit of time to copy zeros into a file means that it will take at least that much time when I test it right here. So let's do that. Let's see. So I'm going to run this guy. Oh, that was very fast, actually. This is very fast. And all the data's still there. What is going on? Never mind. Sorry. Install shit. Oh, it's because the vertex buffer. So I need to do the same thing, but for pass, which is my pass through vertex shader. That's the file that it's actually reading. It's reading pass.tvs, not the other one. And then I get to put a, let's see, we'll put a breakpoint here or something like that. Just so I know I'm reading the right file. Okay. Vertex file. What vertex file am I reading? Pass.tvs. Okay. And pass.tvs is now... Oops. Not head. Well, that's a good sign. ls. Good. It's now 1 gigabyte. Great. So when I do this, it should take some amount of... It'll get here instantly. Oops. I didn't mean to start it from the beginning, but... Okay. Oh no. Oh no, my valak database is too big now. Oops. Maybe a gigabyte is too much. So we'll do 100 megabytes. We'll do 900 megabytes. Yeah. 900 megabytes. Yeah, that's better. I have to remember not to check this stuff in. I do not want to upload a gigabyte of crap to GitHub. Just in case, we'll get rid of mgui. We'll revert that back to what it was before. That took a perceptibly long time. Yeah, turns out reverting a gigabyte large file is not immediate. Okay, so where was I with that? So now I have to go clear out this. Yeah. Huge buffer that it allocated. But should work from here on out. Oops! Oh, I didn't mean to do that. I closed Xcode for no good reason. Open it again. All right. Sorry about that. What was I doing? I meant to just close this file. Whatever. Play. Oh, come on. It's still too big. I thought I turned off the Mallet Grotto. It's nice and small now. Oh, this thing. Yeah. Git checkout. We'll do that. Perfect. Ain't no game of mine has a gigabyte memory footprint. Forget it. Okay. So here we are. We're about to start reading stuff. So we should get to the think function immediately. Bam. But it's probably not done reading. Oh, it is done reading it. How did it finish so fast? What? Maybe it's just because I've been sitting here in the debugger and the OS did it in the background. So let's do this instead. Let's put the breakpoint right there and then see how long from when I press the play button it takes. That was not very long. That was really not that long. What? To read 900 megabytes of stuff. I'm not sure I believe it. I'm not sure I believe that that's how long it took. That was really fast. Let's try it again. Yeah, that was like almost immediate. Do I believe that? Let's look at the actual data that it's looking at. Buffer size. Oh, look at that tiny buffer size. Oh, because it finished the other file real quick. This is reading 2 files, of course. Of course. Let's get rid of one of them then to make sure that it is doing what I want it to do. Oof. Now what? Oh, this is silly. There we go. Bam. So that was a perceptible amount of time if I've ever seen one. Okay. So that took a moment. And it rendered black. It rendered a different color. But the question is, can I press escape? And I can! I can press escape. So that means that the main event loop was running and caught that escape while the, while everything else was going. Like while the thing was loading in the background, the event loop was still running. So it is truly asynchronous. So that's great. Love it. Let's try it again. Escape. Escape works fine. And if I don't press escape, not pressing escape, it's going to come back here, finish the async read. My buffer should be full of zeros. It is, because we wrote zeros to the file before. So we'll step into this guy, step into here, and now it's just going to be junk. It might even give us an assert or something. Yeah, because it doesn't recognize all zeros as a valid file format, which is fine. That's legit. I shouldn't have written zeros to that file if I didn't want that to happen. So good, we have actual asynchronous loading going on. Although 900 megabytes in that amount of time was a lot. Like, I just loaded 900 megabytes off my hard disk in like a second. Hello, I just want to say thanks for your game dev math videos and docs.gl. Both of them are great resources. Thank you. I appreciate it. Yeah, I'm going to be getting back into math videos. They're going to be like more interactive videos that are actually a website. That's kind of the medium to long-term project that I have going on. So we'll see if I can ever actually finish it, though. Yeah. 900 megabytes, almost a gigabyte, in like 1 second. That is kind of scary how fast that is on my SSD. Probably if it were a spinny drive, it would not be that fast. I wonder if I have a spinny drive or an SSD in my other computer. I wonder. I wonder. And I also wonder what the difference in read time is between the two. Ugh. I have no way. I have no idea how to get Windows to tell me what drive that is. I think I can just Google the device name. Asus DRW. I think I bought a solid state. I don't even remember. F24F1ST? Oh wait, that's the CD. Is it? Yeah, I typed the wrong one in. It's this one. ST what? I'm just typing a bunch of numbers that I see on the screen here. Seagate hybrid drive. I bought a hybrid drive? I don't even know, man. It's a terabyte? Is it really a terabyte? It is a terabyte. I do have a terabyte spinny drive. Okay. Good, then I'll have to test this on my spinny drive. Wait, I don't understand. It's solid state? I bought a terabyte solid state drive? Wow, that must have been expensive. Okay, I apparently spent a lot of money. Oh wait, not that expensive, I guess. Okay, well, that's fine. All right. So I don't actually have any spinny drives to test this on, which is probably fine. If I have a USB drive, I can try loading it from there. That's a good point. I do actually have a USB drive, and I think I do want to try that. It's a USB solid state that is apparently very dusty. Yeah. Oh, what can I unplug here? I'll have to unplug the tablet. That's fine. I don't think I'll use it. Yeah, it's probably, you're right, it's probably caching it in the it's probably caching it in the cache. Okay, actually, that is the next test. Let's write out a new file and see if it still loads it as fast. So that's a good point. And I'll write it from dev random this time. So let's see. Dev. No, it'll still be in cache though. It'll still be in cache because... Oh, that takes a while, actually. Yeah, because it's got to generate all the random numbers. It'll still be in cache because I just wrote it out, you know, with this dd command, and so it'll still be in cache when it reads it back in. I don't think there'll be too much of a difference with a USB solid state drive, but I might be wrong. It's got to go through the USB bus, which is not really a bus, so there might be some difference. Yeah. Wow, this is taking a while, actually. I wonder if I should let that go or stop it. If there's a way that I can like clear out the cache, but I don't think I can do that other than by loading a bunch of other files. I could do that. I could just like, you know, guess how large the cache is. It's probably a few like megabytes or 100 megabytes or something like that. And then just no, there can't be a gigabyte cache on this drive. It can't be reading the entire drive, an entire 900 megabyte file entirely from cache. I'm not sure I believe that. A gigabyte of cache? Let's see what the cache was on this thing. Is it gonna say that here? Specifications. Cache, see? Cache is only 64 megs. And, oh well, flash memory capacity is 8 gigabytes. Oh wait, does that mean that it's a spinny drive with a... I think that means it's actually a spinny drive. Yeah, okay, it's SSD-like. Okay, no, it's... okay. That's why it's so inexpensive. It's just a spinny drive with an 8 gig cache in front of it. That's what it is. That's what it is. But in my Mac, okay, hold on. Catching up with chat. Don't think there'll be too much of a difference between USB, yeah. Only if the file is huge. That HDD would be a good test case. Perf on them tends to be pretty bad. Yeah, that's why I want to try it on that. But that's on the Windows box. I'm not going to do that right now. A cache on a hard drive would be anywhere from 8 megabytes to 64 megabytes, I believe. Yeah. And our gigabyte file is way bigger than that. Your other drive was a spinny drive with a small amount of flash to load your OS faster. Exactly, yeah. But that's on my other machine, so... well, let's just try this. Let's just try this. The cache for this thing cannot be that big, so... I wrote a bunch of random crap into the file, so hopefully it's not optimizing all the zeros out. So let's try that. And run it, and... Ah, see? That took a little longer. A little bit longer. And probably it'll be a bit faster now. A little bit faster. Yeah. That first run, though, was like maybe twice as long. So, let's try it off the USB drive. So I just plugged that in. Where is it? Volumes. My passports. Okay. Stuff. Got some stuff in here. You guys are gonna see all my stuff now. Okay. Where's my mouse? Stop. And my passports, and then, yeah. How big is it? Get info. Okay, 500 gigs. That's plenty. And most of it is, wait, did I read that correctly? Most of it is available. So let's put a big file on it. A big random file that will take a moment to write. Volumes, my passports. And then just, you know, crap. Oh, read-only file system. Oh no. Why is it read-only? Oh, I would have to format it. Damn it. Okay, well this test is not happening today because it's formatted with Windows stuff. I'm lost. Just showed up and have no idea what you're testing. Sorry, Captain Kraft. I'm looking for a slower hard drive to test async file reading. Could you put a sleep on my async read? Yeah, I could probably do that. I mean, so for the purposes of like, and to just explain to Captain Kraft, in video games, a lot of the times they load things in the background while you are like walking from place to place so that they don't have to show you a loading screen. And that's what I'm doing. I'm making an asynchronous file reader that can read something in a background thread while you're playing the game. And so that when you load it up, when you load the game up while you're playing the game, it doesn't like interrupt you. That's what I'm doing. And yeah, currently I'm trying to find like a really slow thing that I can load it from. So like, for the purposes of actually figuring out if it is truly asynchronous, I think I've done that to my satisfaction, right? I've just like, I was able to press escape while it was still loading the file. So I don't think asleep would help me like in that respect. And actually, like my async read is done by the OS. Actually, I couldn't even put asleep in there because my async read is done by the OS. I don't have a separate thread of my own that's reading the file. The OS is doing that, and I don't have access to its thread, so I can't put asleep in there. Like if I put I only have one thread in my, well, I have two threads, but the other one's a render thread, and it's not doing any IO. Like if I put a sleep in my thread, the whole program will freeze, for sure. So I don't think I can do that. But actually, it just occurred to me that maybe I can just read like an existing file off of here. Where's a really big file that's already on this thing that maybe I can just read? Volumes, my passport -L. Here's one. How big is that? 32 gigs. That'll do. Okay. So in order to do that, I think what I have to do here is overwrite this with the name of this file, which I think is a bunch of photos that my wife took when she was overseas once. And she's storing them on my drive, which is fine. Which is actually convenient because now I have a 32 gigabyte file to read. So let's see how long that takes to read. That should take a hot minute. Oh yeah, this crap again. Shit. Okay. Now, so Valak doesn't like allocations that large. That's fine. I'll just use malloc for this thing. Malloc there. No problem. The OS does, in fact, provide asynchronous IO, and that's what I'm using. I'll show you that code real quick. We were looking at it before. Platform OSX AIO read. So this is how to do it in most Unix-based systems. Actually, do it this way: AIO read, AIO error, and AIO return. So AIO read just means, hey, start reading. You pass it this control block. I was fighting with those. Yeah, I'm gonna malloc 32 gigabytes. It's gonna be great. It'll work fine. Nothing will go wrong. It's a 64 gigabyte system. It's a 64-bit system. So I have 2 to 64, which is an ungodly. It's much larger than 32 gigabytes. It should be okay. 2 to 64. Yeah, that's 19 zeros. 1.8 with 19 zeros, so it should be okay. So yeah, you give it the buffer you want to read into. You give it the... Oh, actually... It might not work. It might not work. If this function doesn't support it. Well, we'll see. We'll see. We might break everything. Let's try it. No matching function for call to malloc. We can fix that. Man, malloc. Studlib.h. Oh, I keep forgetting not to modify things in this file. Okay. I'm going to modify them here in Sublime. Include studlib.h. No max. Oh, yeah. Got to get rid of all this crap. All right. Maybe I should just step through this code just to make sure nothing crazy is happening. Okay. So, read.buffer size, 32 gigabytes. Works good. Allocate that thing. Start the asynchronous read. Great. So now let's continue. And, well, you want to stop here. Interesting. Maybe it failed. Let's see what's going on there. Bytes read -1. Yep, it failed. It failed. It failed. It failed. It failed. Okay, maybe what we can do instead is limit this to kilobyte, megabyte, gigabyte, 3 gigabytes. Oh wow, this is getting to be really gross. But just we'll read 3 gigabytes instead of... We'll read 3 gigabytes of image data instead of, you know, overflowing expression. Oh no. Let's read 1 gigabyte. So this is what I meant by... I don't know, you get sizes this big and things tend to go wrong. But it's fine. It's fine. What I really want to know is how fast it is to read this amount of data off of that. So 1 gigabyte should be fine. No sense in pushing the envelope. I'm never going to actually read 1 gigabyte of data from... A AAA game might have that much data, but it'll never be in a single read. And, yeah. My game won't. Okay. So what am I doing? Start the read. Continue. Yeah. So that's taken a good long time, actually. Bam. So how long was that? I don't know how long that was. It was a good, like, 7 or 8 seconds or something like that. Let's see it again. Okay. 1, 2... Oh, now it's in the cache. Now it's in the cache, so it's a lot faster. Yep. That was, like, immediate. Hold on. Check and make sure it didn't. Yeah, so it read all those bytes. But it read them from a cache. So that was, like, 7 or 8 seconds. Let me change files again, just in case. Let's see here. What else can I? There's some really big files in here, probably. Yeah, these are all really big. Let's try some of these instead. Got another measurement in there. I'm not even going to try and explain what this is. Some random ass video footage I took a long time ago. Oops. Okay. So. One, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. And the funny thing is that it said disk 0 kilobytes for the entire time. Probably it's because I was reading it from this thing, not from the disk. But so that was an interesting experiment. But I'm not sure like how well that emulates a spinny drive. Because like the sustained read of that file through the USB bus, like it's all solid state there, so it's going to be different than the sustained read off of a spinny drive. So I don't have any spinny drives available right now, but once I get one, I can do a better test of the sustained read times of a spinny drive. In the meantime, I'm just going to revert all this stuff. That wasn't interesting. So that's interesting. That means that, wow. Okay. I think what that means is that games take too long to load. Basically. Basically, that's what that means. Right? Because just reading things off the drive should never take more than a few seconds. Like, if I can read a gigabyte of data off my drive in 1 second is what it was when it wasn't from the external drive, which I'm gonna. Right. I just read like a gigabyte of data off my local drive in like. Yeah, this thing's warm now. In like a second or two, and theoretically, I should be able to load a game of about that same size in about that same amount of time. So I wonder why it usually takes longer than that, you know? Like if I load up a game of like I don't know, Battlefield 1 or something, it takes a little bit longer than that to load. So that's interesting. What is it doing there? It's doing some processing that maybe can be gotten rid of. I don't know. So all right. Oh, I'm gonna go revert this gigabyte file that I made. Pass.tvs. So this should also take a perceptible amount of time. And it did. Just like a quarter of a second, but that's funny. I find that funny. Okay. So good. So where were we with that one? Good. So we verified that this actually is an asynchronous read. So now we load it. We load it. And then I should probably get rid of this junk. Good. I don't want my memory database to have like 900 megabytes in it. So we go to load it, and now we have to actually send the code over to the renderer. So let's do that. Include vtb render.h. vtb render.h. I think that is a file that, good. So now vtb render.h. All right. So maybe it calculates stuff like vertex normals for meshes and calculates texture atlasing for optimizing texture calls and stuff like that. Yeah, but how much of that can be done offline? You know? Like, I wonder how much of what a game does when it loads can be moved to offline processing and how much really has to be initialized in the engine. Kind of like by definition, almost by definition, if you if you're doing processing on load, you can also do it offline. Can't you? Like, I'm trying to think of what games I've made previously and what processing I've done on load. There is a trade-off between file size and loading time, you're right, but like I've had it before where I have a level and I build like a quad tree of the level on load, but you can build that quad tree offline. I don't see why you couldn't, and then like your quad tree is just available. I suppose there are things you have to do like hook things up at runtime that like when you're they're usually deserialization steps. Like it's not so simple as with my library where it's in memory and now it's done. It has all the offsets and it can access all data immediately. There are things you have to do often after the game loads. But I don't know, how much can you minimize that by pre-computing? Like computers are super fast these days and you should be able to burn through all those pre-computations pretty quickly. With multiplayer games it's a little bit different because you have to synchronize a server and a client. So like the server has to load and then all the clients have to wait for the server to load completely. And then they all start loading and then the server has to wait for all the clients to load completely, right? Like that's like the really straightforward way of doing it. It's, having them both load at the same time can be tough. Or at least maybe they can both be loading like assets at the same time, but they have to initialize their world. Like the server has to initialize this world and then like send all of the information about the world to the clients, and the clients get that, and then they they use that information to create entities and stuff and that sort of thing. So like that can happen serially. And it's something that can't be done offline, obviously. I see. This is weird because I've also heard of like there's a thing called VOGL. VOGL, which is the Valve OpenGL capture and playback debugger. The guy who wrote this, his name was, I think it was Rich Geldrick that did this. Was it? Let's see. Well, maybe there are other people doing it now. I don't know. Not sure. Anyway, whoever wrote this, I think it was Rich Geldrick, though, who talked about this. I may be mistaken. Who knows who it was? In any case. So they use this tool to, like, this tool sits between your game and the OpenGL driver and just intercepts calls and then like dumps them to a disk and then reads all those calls back later and feeds them back into OpenGL, and so you can like run a playback of the game. In order to do that, it has to basically store your entire game in some dump on the hard drive. But it's apparently, like, I heard one of the developers talking about it, how it's really fast, and they just, like, zip all that stuff off the hard drive, load it into memory, load it into the GPU, and it was super fast to do that. It was in the order of, like, a few seconds, or maybe even less. This is all hearsay now because I don't remember where they said that, but, like, they said that they got the same performance with VOGL, which just loads all the render data from the hard drive, but, like, gigabytes worth. Huge render data. And then feeds it into the driver, right? So probably we can do better at loading video games, but I don't know. Maybe there's some complexity that I'm not aware of yet, so I should not run my mouth about it, honestly. It's probably a good idea. Probably a good idea. So VTBR, what is this? What is this? Do I have enough time? Oh, it's 9 o'clock. Yeah, I shouldn't get into this. But I'll explain what I intended to do, which is, and I probably would have gotten into if I hadn't spent 2 hours figuring out how to get the asynchronous crap working. Whatever. So this is like a renderer library, kind of. You, like I want to have a really clean break between the render thread and the non-render thread. So the intention is that like you fork off a render thread and then you point this, and then you start this library, and then it will do all of the synchronization for you. You just tell it, hey, render this, render this, render this. And then it stores those up in a queue. And then every so often you say synchronize, and then it sends that queue over to the other thread and starts rendering stuff for you, right? So That's the intention of this guy right here. It's like the part of a game engine that's like the rendering part of it. That's just the really low level rendering part of it. And then maybe like it's like the rendering back end of a game engine, except I'm hoping to get it pretty agnostic to like everything. Like hopefully it has no dependencies and it just like, well, SDL is its only dependency, and it just takes command buffers and spits them out into the into whatever graphics library you're using. So that's my plan for this guy, but it looks like we're not going to get into him tonight, unfortunately. I already have some stuff hooked up, obviously. It will get inputs for you, which I'm not a... There's a whole discussion about whether a rendering library should do inputs up here, but hopefully I can do something about that. But anyway, inputs. So it already does some stuff, but it doesn't actually do any rendering stuff. Yeah, like a task pool. Well, like this guy. This guy. This is the rendering thread up here. Where'd it go? Oh, I unplugged my tablet. Oh no. Well, no, I think this is worth plugging back in for. Oops. Where's the cord? Where's the cord? It's this one. Come on. Hello. The lights are on, but nobody's home. Oh, there we go. So this guy, the main thread. So this is the logic thread, right? This is where all the game logic happens. And then at some point in the game logic, you say like render. You call a render function. And then it walks all of your game entities and says, hey, you, render yourself. Hey, you, render yourself. Hey, you, render yourself. And each entity says, okay, well, this is my model. And so send my model to the renderer, please. And the model's like, okay, I'll send myself to the renderer. Well, I'm really just a vertex buffer and an index buffer with these uniforms, with these configurations, right? And so you take that data, and that's what it's doing right here. That's what it's doing right here. You take that data and you form a command queue, like a frame buffer, a list of render this thing, render this thing, render this thing. The actual data is not there. The data was previously sent to the GPU, right? All you have here is a handle, like render this handle at this location, right? Like that's the kind of data you have. Render. Actually, maybe I can even show you some code. So this is as far as I got with the previous interface. I want to duplicate this interface for VTB render. So like draw buffer array, okay? And you give it a previous buffer array that you've already sent it, and then some special information about the buffer array, and render options. And you send all this stuff. You just dump all of this. You just call draw model, draw buffer array, draw quad, draw text. Now blit frame buffers, you know. And then it stores in memory a list of all those commands, a command queue. And that's what it kicks off to the render thread. So what I want to do is basically this thread right here. Every game has one, right? Like, well, every game, like every large game engine has one. And then it starts walking through this queue and actually submitting the things in that queue to the driver. It starts firing these guys off right here, these arrows off. It just walks the queue and it doesn't even know what it's rendering anymore. Like, that's why I'm saying it's completely agnostic to the game. It doesn't know it's rendering whatever model it is in your game, a car or a gun or a player or whatever. All it knows is, oh, render this vertex mesh with this at this location or whatever, right? Completely agnostic to the game. It's just kicking tasks off into the driver. That's kind of what like. Every game engine has one, and I don't really know anything about writing them, so I don't think anybody should use the one that I'm about to write. But it's an interesting exercise for like, can it be written completely agnostically of the actual engine, you know? And so when I'm done with it, you know, other people can use it. They probably shouldn't because I'm not an expert on this sort of thing, but in theory. Why should every engine have its own? You know, is the thought that I had. Every engine has its own and has to write its own thing, which is probably a good idea because every engine is built for a different purpose, and its render layer has to fit its purpose well, and so having a special one is maybe a good idea, but I don't know. I honestly, it's just sounds like it'd be fun, so I decided to write it. That's the only reason. Anyway. So that's when I want to start developing next time. Start developing this thing and actually, you know, start pushing commands to it. So, but it's already 9 o'clock, and 9 o'clock is my bedtime, folks. So thank you to everybody who dropped by. I had a great time. Sean took over my channel again. It's always great when he does that, and he left me with a list of things that I'm gonna have to learn about. So that's fun. Feel like probably people followed this guy more than they followed the stuff that I did last time with the compiler. So I'll probably continue on this for a little while, for as long as I continue having fun with it. Does it happen every frame or only when you mark a buffer dirty? I guess in a game that would have to happen every frame. Yeah, it would. Like, it's not going to render anything unless you tell it to. And in fact, I think the correct behavior is for it to wait. Like, you have to give it a new command buffer every frame. And if it doesn't get a command buffer from you, it will block and render nothing. Because if your game is not like done processing all the game logic in the 16 milliseconds or whatever that takes, then that's a problem with your game, and I'm not going to try and like write around that. At some point, like, yeah, at some point, if your logic thread screws up and has an infinite loop or something, I'm not going to just re-render the last valid frame over and over. That's complexity that I think is unnecessary. So if you don't give me a new frame, I'm not going to render anything. I'm just going to wait. I think it's the design that I want to do. So yeah. Yeah, again, thank you everybody for coming. Had a great time. Same time next week, 6 p.m. Pacific Daylight Time. We'll probably do more of this rendering stuff. I don't know. I might feel like doing compilers, though. Maybe we'll bounce back and forth, depending on... Because I code this on my spare time over the week. And you're welcome. And maybe I'll be into a more interesting thing in the compiler at that point. So we'll see. I think Android OS takes care of the UI rendering in a similar way. Sure. Yeah, like... asynchronous rendering is in a lot of stuff. For sure. All games do it. You know, all games that you've heard of do it, basically. Or I should say, all large games from AAA studios do it. Like, Minecraft probably doesn't do it, for example. But, I mean, they could. But it was just written by one guy, and it's... yeah, for sure. And it's not only just games, but like Windows does it and Android does it, and so it's pretty common. It's a good thing to learn about, even if you're never going to write it. To actually know what's going on behind the scenes. I think it's interesting. Okay, I'm signing off now. Thank you everybody for coming. Had a great time. See you same time next week. Yeah, streams going up on YouTube, etc.